Welcome, Mr. Risley, to the pod. We know you're a meteorologist and weather forecaster, but give us a little bit about your background as a high school multi-subject teacher, also a university professor, and your experiences as a meteorologist, a weather reporter for WGEM, and of course, famous storm chaser and spotter.
Okay, well, I realize I wear a lot of hats. So if to go back to start, I originally went to school to be a meteorologist, and I didn't really enjoy math and physics as much. It's just I'm more of a humanities, social science guy. So a couple of years into it, I went to a community college first, and then I transferred to Illinois State University, which is a 4-year degree university here in Illinois. It's a big teachers college. At that point, I had made the decision to switch to education. But I originally, went to school with the goal of being a meteorologist, and then but math and physics is of course essential. Like it's a core component of meteorology. And so if you pursue that as an actual major, there's a broadcast route that I didn't think of going at the time. I'll get to that in a little bit. But I always liked history and like political science, law, stuff like that. So I thought, I like teaching. Like I like working with younger people. So I switched my major to education. I kept my minor in geography with a physical geography, atmospheric component as a minor. And then I ended up pursuing the teaching route, going full time into teaching. So where this went was when I decided to go to graduate school, I pursued a master's in school administration. So in Illinois, that allows you to be like a building principal or a financial officer. You would be like a dean of students. So I have my master's degree in that. That's what segued into the university professor, which I'll get to that, or I'll circle back
Yeah,
around
no
to
worries.
that. But I started storm chasing when I was 17, just going out, following storms, being interested in them. Now, if there's another question here, we'll get to where that all started. That's separate from like the professional thing. And my friend Ryan Weekman, who's now in Toledo, he went to Western here. He's a graduate of our meteorology program. He got a job right out of school at WGEM. He was their weekend meteorologist, and he's the one that got me in with the station. This now I'm going back
Gotten in.
16 or 17 years here to where I would go on air and they would call me, because I started storm chasing more like very locally. I grew up in northern Illinois, closer to Chicago. It's a town called Streator, southern LaSalle County.
Okay.
And then I would like start going regionally, maybe like an hour or 2 hours away from that. And then it translated into later, let's go out on the Great Plains. Like, let's take week-long trips. You kind of get bigger as I got older, had more money. When you're young and broke and you're just
Scraping
jumping
by.
in the cars scraping by,
Yeah.
kind of going locally. You're not thinking about, I'm going to go to Kansas for a week.
Right.
That comes later. So Ryan got me in with WGEM. This would be about like 2009, 2010. He was there for 2 years. He left in 2011. So I had the in there like on air. So when there was severe weather, there was tornadoes. They go wall to wall. That's like an FCC thing. Their live coverage. There's a tornado warning. They would call me up, and I'd be in the field. I'd be on the phone telling them, "Here's what I'm seeing. Here's what's happening in the field." And so that established that relationship with WGEM, which is our local Fox and NBC affiliate here in Western Illinois. So I had that in with the station. This was all like while and after I'd finished my master's degree. So I started working with Western. Western invited me, this is about 7 years ago, to come teach courses for them in their school of education. And your dad is actually part of the school, is one of our faculty members. And so that was more because I had the background in school administration, I had the teaching experience, and I've taught street law or civics at the high school level for a long time. They asked me to come teach for them. So I teach education law to people that are going to school to be teachers, and I also teach a couple other like social studies, pre-service teaching courses. So one day I get a phone call from WGEM. So this is going back, 2020? It's about 7 years ago, right before COVID. And it's kind of like how Western happened, hey, we could use some help here teaching some of these courses. And it was the station manager that I had this relationship with from doing the on-air phoners from 10 years prior. And he said, hey, I know you have a background in meteorology. I'm not actually a meteorologist by trade,
Right.
we have some turnover, we have some vacancies, somebody was out sick. There's like, we could just kind of use an extra person to come fill in and help here. You know enough about weather between being self-taught and I teach geography too.
Mhm.
So being a geography teacher, part of geography is physical as much as it is. So you do what weather, climate,
Right.
solar system, things like that, physical features, tectonic activity, Pangea, all this, stuff. But anyhow, so they asked me to come into the studio and talk about maybe helping fill in. Just to be like somebody to fill in when somebody's off sick, has vacation, they have needs a few times a month.
Mhm.
So I went in and we talked about it, and I'm like, well, I don't have a communications background, like zilch. No communications background at all. My background's all in teaching, but I have the weather, the atmospheric geography background. And so we did some work with the green screen, on air. And they said, would you be interested in doing that? And I said, sure. Yeah, I think I could learn. What I would be coming in with is the knowledge. What I don't know is what it takes to be on, because being on TV is different. Like,
Yeah.
you have to tell a story. You have to make the people feel you're sitting there in their living room with
Need that
them.
emotion.
But you also have to know how to take a weather forecast, and it's different than being on the phone when there's a tornado. You have to take the weather and bring it down to the level of the ordinary viewer, which teachers do the same thing.
Right.
When you're teaching, you're bringing it down. You have a level of expertise the students don't have. You have to bring it down to the level of the student. That was actually the most difficult part for me, because I'm sitting here throwing out terms that I'm used to using, like upward vertical velocity or shortwave. These are all meteorology terms, but viewers don't know what you're talking about. So
Right.
you have to be very basic and talk in terms of like fronts, air, which it's just like anything else. It's like if I take my car to the mechanic and they start talking about something like sway bar links. It's something I recently learned about. I'm not, overly, but like, here's what it does and here's what's going. You're gonna have to do the same thing. So we went through a little training and did that. Like, you're used to being up in front of people. You can do that. So after a few weeks, they're like, yeah, let's do this. Let's run. Let's get him. And that was a little rough at first, but I feel like I fell into it and got the hang of it. And once you learn how to do the TV angle, things kind of fall into place. So I've been doing that now for 7 years, and that's what's translated into the third thing here, which is this this side job on air doing weather. My official title is weather reporter on air.
Does that, for being a weather reporter, I know you said you had some kind of setbacks of getting used to being on TV. Has that been difficult, and like, has that been easy to overcome, I suppose?
Yeah, I would call it like a first world problem. Like, it was certainly nerve-wracking because it's a whole new thing. I never had any. I think I had one speech class in college, and that's it. I had no formal communicate. I just didn't take any communications courses. Where when you're going to like radio, television, broadcasting, that's a whole major. Somebody can, or a minor. And so you have a lot of courses that teach you how to effectively be a communicator to a large audience through a mass media venue. And I didn't have that. I had tons of experience public speaking through teaching in various other ways, that can come about. But it was a little bit nerve-wracking that, I'm going to have 80,000 people watching me when I walk in front of this camera and it goes live. But the biggest thing was getting used to the green screen, and also when your presentation, because it's not like standing up in front of a class and teaching. It's timed. And weather's the only part of most newscasts there's no teleprompter. It's all
really? Wow.
Okay.
Yeah. So your sportscasters, at least at our station, and your
local news,
your local news, your desk anchors, they're reading off teleprompter. Weather is not reading off a teleprompter. So it's all ad lib, but you also have a time limit. Typically, the typical time limit in our market's 3 minutes and 30 seconds. They can give you more. That's the floor. The ceiling could be, 4 minutes and 30 seconds. But you have to do all this in that time, and you have to put together your own show. but you need to be able to communicate to the viewer what's on their level. So you can't sit there and have a technical meteorology discussion.
Gosh,
They just, people just want to
that's
know
crazy for me.
what's going on, what's going to happen. Bring this down to my level.
Yeah.
And so that took a little bit of getting used to for me.
With how in depth you've been with weather the past seems like about a decade, was there any like childhood, early youth experience that really spurred this? Because it sounds like this was a lifelong
Yeah.
passion that stemmed when you were really young.
A couple things. I believe I'm right here. The only F5 tornado in Illinois in August happened in 1990 in Plainfield. Plainfield's a suburb of Chicago. So I was the fall of my 5th grade year, and I remember going outside that day and we lived, I want to say 65, 70 miles southwest of Plainfield. I can remember going out that afternoon and seeing what we call cumulonimbus clouds, like thunderstorm clouds, like really tall. And we're talking, I'm guessing with that storm, probably 60,000 foot tops. I remember seeing those clouds and being fascinated from that far away, like, wow, like that's really cool. I don't remember seeing something like that from that distance. We'll come to find out that night on the news, this devastating tornado it absolutely decimated part of Plainfield. So that next, and we're going back 36 years here, so I can't remember how many days later it was. The closest mall to us at that time was Joliet. So we would always go to the Joliet Mall. And Plainfield is proximal to Joliet. So at some point after this had hit to where you could get into the subdivisions and actually, so access was somewhat opened up, it wasn't all sealed off, we went and did a family trip to the Joliet Mall. And I can remember Nintendo was the gaming system at the time. And I had a magazine, you know, Nintendo, the old Nintendo. My dad said, "We'll put that down. We're going to drive through where the tornado hit." And I can still picture it like it was yesterday, driving through some of the subdivisions and seeing that and just being absolutely fascinated with what could cause this level. Because, I mean, an F5 tornado, now that's the old Fujita. We now have the EF scale, but still, that would still be an EF5 tornado. They've just made some changes to the damage scale to better reflect things like structural integrity and building codes and things like that. I mean, you had homes that were basically leveled down to slabs.
That is
or like little left, but maybe fractions of walls on the lower level. I mean, 3 or 4 feet of a wall left. And of course, there were, if I remember right, several dozen fatalities. And I just can remember thinking all that came from that would have been an updraft or the back, you know, that cumulonimbus cloud that I saw, and just absolutely being fascinated with that. Well, probably one of the most famous meteorologists in the country, Tom Skilling. He worked for Channel 9, WGN, Channel 9 in Chicago. He just retired, I think it was earlier last year. Tom did a presentation every year in Fermilab, which is up in Batavia. They came out with a documentary called It Sounded Like a Freight Train. And it focused on the Plainfield tornado. And so that I can remember, you know, watching that as a kid and being fascinated. And then, you know, growing up, then you're now old enough to kind of understand what's going on because I'm getting into be a teenager. And okay, we have tornado warnings and seeing these like, so I never actually personally lived through a tornado that hit like our community. Although, fun fact, in 2010, Streeter got hit June 5th, 2010. It did actually tear the roof off of my childhood home. But we didn't live there anymore. So it was just those formative things that happened as a kid that I can remember kind of igniting my interest in it a little bit. Another infamous tornado, Andover, Kansas, April 26, 1991. The next day, there was some severe weather as the system moved east. I can remember my dad getting us into the car and we went and followed. There was a funnel cloud. Actually, kind of. So little things like that really just basically fascinated me as a kid. You know, a young kid, you know, a burgeoning teenager, that I wanted to learn and understand more about this process, this phenomenon.
Could you explain the difference between an EF1 through an EF5 tornado? Like you mentioned that damages, is it based on like cost of rebuilding, how severe the damage is? What exactly does EF stand for, if you
Okay,
will?
E and EF, Dr. Ted Fujita. So we're going back mid 20th century. I think Dr. Fujita passed was 1998 or 1999. He is one of the foremost, if not the most well-known researchers on tornado genesis, tornado climatology. He did extensive damage on what causes tornado, or I'm sorry, not damage, extensive research on what causes tornadoes and the impact of their damage. One of the focus areas of his research was how to quantify. So the scientific need to quantify things. How do we quantify tornadoes? Like, because they're not all a little thin road. And by the way, size and wind speed are not coterminous. You can have large tornadoes that are weak, and you can have smaller tornadoes that are very violent. Gerald, Texas, for 1987 is an example. But just for the purpose of our discussion, you can have a little thin rope tornado that's got 90, 100 mile an hour winds. That's like an EF1 that does minimal damage versus an F5, which will do absolutely, or EF5, which will do catastrophic damage. I'm bad about it because I grew up with the Fujita scale, and now we have the enhanced Fujita scale. So
Yeah, no, you're fine.
I get them
No,
mixed up, or I use them interchangeably. But an EF1, so an EF5, you're talking like 200 mile an hour winds or more. An EF1 is going to be, you're looking at like winds closer to like 100 miles an hour. So they're rated based on forecasters and damage survey experts will go look at where the tornado hit, and they'll take a look at how was the structure, how sound was it, like what was the construction like. Like a well-built brick home is obviously different than a mobile home on a flat.
Yeah.
So an EF1 tornado could do substantial damage to a mobile home on a slab, and they're not all anchored very well. It is not going to cause substantial damage to a well-built brick home. You might have some windows broke, you might have some minor roof damage, some gutter and awning damage, but it's not going to compromise the structural integrity of a well-built brick home. A more serious tornado would. A weak tornado can absolutely tear up, your shutout back.
Yeah.
It can do a number on a mobile home or any type of a poorly built structure. So they're really looking at like what was the structural integrity of whatever was hit, and also things, because it's not all buildings either. It can look at things like in fields like irrigation pivot systems, high tension transmission lines, telephone poles. There's all different types of like items or structures that are damaged by a tornado, and they'll look at, well, what type of wind speeds were necessary to cause this. A plus B equals C. And so it's really just trying to quantify how strong were the winds in this tornado, since we don't often have a record, and even if we do, it's just like in one particular place in one segment.
Yeah.
How violent or strong was this tornado, and what does it take to do this? So we kind of have an idea of what we're working with here.
Gotcha. Yeah, no, I appreciate that. I was thinking about the trains that got flown
Same.
off the track,
Right.
And it's hard to imagine that until you go see it. So I was driving by, I saw them knocked over, and I was like, I was just like, it's incredible.
Yeah.
I mean, and it's just really severe, like you said.
And I think if I remember that this tornado just happened, what was it, last Thursday?
Yeah.
I want to say it was an EF1.
Okay, yeah, see, it's just like toss it off the track like it was nothing.
But in there again,
Right.
you're dealing with the physics of what it takes to overturn a train car is absolutely different than this is a well-built, or it looks to me like a well-built home.
Yeah.
So it's not going to, that
Right,
strength
difference.
of the tornado is not going to lift this house off its foundation and do to it what it did to a train car.
Right.
Weight, structure, train cars aren't, all those factors go
Right.
into play.
Right. Still, it's incredible to see, and
But
it's hard
Absolutely.
to really get a
what
picture of it.
causes this? Sure.
I was reading a book earlier today, and which is great timing because there's a section on misinterpretation or maybe misunderstanding what you do, forecasting and reporting. Because like the average layperson, man, it was really hot today. Thanks, Mr. Risley. You made it hot today. Or that tornado that destroyed my aunt's shed last week. That's your fault. I'm gonna get you for that. So I really want to read this section because I think it unleashes something that we probably don't think about in terms of like the association principle. So this article excerpt is called Weatherman Pay Price for Nature's Curveballs by David L. Langford. And this is from Robert Cialdini's book, Influence. Television weather forecasters make a good living talking about the weather, but when Mother Nature throws a curveball, they duck for cover. Conversations with several veteran prognosticators across the country this week turned up stories of them being whacked by old ladies with umbrellas, accosted by drunks in bars, pelted with snowballs and galoshes, threatened with death, and accused of trying to play God. I had one guy call and tell me that if it snowed over Christmas, I wouldn't live to see New Year's, said Bob Gregory, who has been the forecaster at WTHR TV in Indianapolis for 9 years. Most of the forecasters claim they are accurate 80% to 90% of the time on one-day forecasts, but longer-range predictions get tricky. And most conceded they are simply reporting information supplied by computers and anonymous meteorologists from the National Weather Service or a private agency. But it's the face of the television screen that people go after. Tom Bonner, 35, who has been of Clark TV in Little Rock, Arkansas for 11 years, remembers the time a burly farmer from Lone Oak, with too much to drink, walked up to him in a bar, poked a finger in his chest, and said, "You're the one that sent that tornado and tore my house up. I'm going to take your head off." Bonner said he looked for the bouncer, couldn't spot him, and replied, "That's right about the tornado, and I'll tell you something else. I'll send another one if you don't back off." So that's just a little excerpt on how people tend to vastly exaggerate perhaps even the job of a forecaster, what you do, because they think, okay, weather's bad. If the forecaster's wrong, it's the forecaster's fault, even though you obviously cannot control the weather in any capacity. So could you speak on that? Like, what do regular lay people technically get wrong all the time about these kinds of situations?
Have you ever gambled?
I have, yes.
Because essentially, what anyone's doing with meteorology, the atmosphere is a fluid dynamic. You're trying to predict the future behavior of a fluid dynamic.
Mhm.
So essentially, it's akin to gambling in the sense that you're trying to predict the outcome of something in the future. The only difference, of course, is you're not involved in some attempt to get some sort of monetary gain from it, obviously, in the sense that somebody is gambling. But I think people misinterpret how hard it really is to predict the behavior of a fluid dynamic in a future point in time.
Mhm.
You are asking someone to make a predict, and also the average person does not understand probability. Like when they say,
Right.
okay, but specifically with weather forecasting, if you get on an app and it says 20% chance of rain, that doesn't mean, oh, it's almost certainly not going to rain. Let's have this cookout or let's have this party.
Yeah.
They don't understand how that figure is arrived at from a probabilistic standpoint. It's very often lost on the jet, and maybe meteorology fails to really adequately educate the public on how probabilities are for precipitation or sun versus any type of weather phenomenon.
So real quick, that's a good example you bring up because I remember someone tried to explain the concept of me when I was much younger about like what is 20% chance of rain mean. But like what does that actually mean?
Okay. Weather forecasters are forecasting for an area, not typically like your house. So in WGEM, I think we have 16 counties. So if they say there's a 20% chance of rain, that's over the entire forecast area. That's based over a whole forecast area. That doesn't literally mean there's only a 20% chance of rain at your house. That's over the entire forecast area.
And what are they using to measure that area? Like to get
Our
that
area is
estimate?
fixed.
Well, I mean,
We have a fixed 16 county area. That's our viewing area, our DMA.
I guess so. I should have said, what are the tools that they're using to measure like precipitation, wind speeds. What are the things that are being used to determine
Okay.
to get you to that 20% number more or less?
So you have your current observations that are being taken all over the country, like Macomb. We have one at the airport. So it's like, temperature, humidity, visibility, but at least once, if not twice a day, they send up weather balloons. Those weather balloons sample what's going on in the atmosphere right now at a fixed point in time. You also have buoys out in, like, for example, the Pacific Ocean, and sensors on aircraft. All of that's fed into model data that takes all that sample information and both gives you an idea of what's happening now and what's going to happen in the future. But then you also have tools like satellite, you have radar, and you can take that upper air data and you can make like actual hand-drawn maps of what's happening at various levels, like at the surface, at 800, what we call millibars, various levels at 500 millibars, like 15, 20,000 feet up. What are our wind patterns? Do we have like troughing? Do we have ridging going on? What's happening with the flow of moisture? So you take all of that into account. What's happening now? What's happening in a different place? What direction is the air mass is moving? Are we having like troughs? And because air flows from like basically between high and low pressure systems, and knowing all that, the behavior of the atmosphere, you can use all those tools to make predictions. And forecasters rely a lot on what's called computer models. But computer models aren't the be and no. I like to say it's all pretend. Like they're simulating what they think is going to happen in the atmosphere and specific in the future based on specific algorithms, but all the models are different. So there's the concept of conceptual modeling, but then there's also taking like what and what you can see happening and applying what the models are showing versus knowing what's really likely to happen, because models have different types of biases. And they'll give you like different, like you could put in a point like Macomb and it'll give you a probability of precipitation, but I could pull up 7 different models, and all 7 of those different models are going to give me a slightly different probability of precipitation. So I can like average that out over the forecast area and say, okay, there's a 20% chance of rain for tomorrow, but that's based on the forecast area. That doesn't necessarily mean 20% here at this house.
Yeah.
And that's difficult for people to wrap their head around.
How dare you not be correct? Yeah.
Right.
But also, 20% chance of rain, the average, you could say 5% and it still might rain.
Right.
But in people's mind, they think, oh, that's almost
it's good enough.
that's almost good enough for me to be. It's not going to rain tomorrow. No, there is still so if it's something that could disrupt an outdoor activity, really, unless, and you could say 0% chance, and you can be wrong. So it can still rain, even if there's, that's a mutually exclusive conversation. But, truthfully, it's when you're trying to predict the behavior of a fluid dynamic in the future, it can be dangerous to always say, like, to rest on your laurels and say, it is not going to rain.
Yeah.
0% chance. Or typically there might be a very low percent chance in there, but as I always say, the atmosphere is going to do what it wants. Humans are just sitting here trying to predict what we think you might want to know about what's going to happen, but nobody's ever accurate 100% of the time.
It's kind of like the map territory dispute. You're trying to make a map of the territory, the atmosphere, using all these models, but the map is never the territory.
Correct.
So your map will get so big, like your map will be bigger than the territory. All these different models, you said 5 to 7 models that you're using at any one point in time. And it's almost like too specific. It's like, it's just the atmosphere. It's gonna atmosphere.
Yeah, the atmosphere is gonna do what it wants.
Yeah.
And you have to understand, humans are never going to be right about it 100% of the time. There's going to be error. That's just how it works.
Yeah. How's the technology from when you were 17, just beginning storm chasing, to like now changed? I know that, for example, I've been listening to a podcast and just the drone technology or you can go buy an off-the-shelf drone, fly it into a storm, and just get a whole bunch of data
Right.
based off of, fairly easy to buy technology off the shelf.
Well, okay, so when I was 17, internet was 56K dial up, and if your mom picked up the phone, and people listening that remember this, you lost internet.
Mhm.
So the concept of field internet was something that wasn't even in my world. Like, oh, how would you ever get internet from a car?
Yeah.
And maybe there was some way to do it through satellite or something.
Mhm.
I don't know, but no one I knew had access to that type of. In fact, I don't really remember anybody getting internet from the field other than early 2000s. You could take a laptop if you had a laptop, and you could. I remember like stopping in small towns at libraries and trying to get Wi-Fi to kind of update, but you didn't have it on a continuous basis mobile until I can remember Blackberries had the capability when the Blackberry came out to tether between the phone and a laptop, and you were still dealing with like 2G.
Yeah.
So it was like 2G slow dial-up speed. That's 2004, 5, 6. Now there was also a program that came out at that point through, I think it's through XM, back early in satellite radio days, where you could get data tethered through Garmin. And there were programs coming out on laptops where you could have you could run radar off a satellite service. So that we're going back like 20, 21, 22. In fact, that's the first thing I did was I had a Garmin GPS that I could pay, I think it was $7 or $8 or $9 a month, and I could have radar on that Garmin. It was a Garmin, and it was really designed more for marine use, but excuse me, I had it in my car. And that's it because I didn't have a cell phone. I think I had a Motorola Razr, a flip phone. I didn't have a cell phone at the time. This was before the iPhone. First iPhone, I think, came out in 2007. So we're not even 20 years into iPhones. I didn't have the ability to get, internet through the phone at the time back then. So if you even go back before then, it was just basically you had a weather radio or a scanner, police scanner, where you could hear warnings and you could find out the direction storms were moving, and then you just use paper maps and follow the storm all on visual. There was no technology in the field like we have now. Today now, I have an iPad that has radar on it. I can access all this model data. I can access satellite, all this on my iPad. Situations in the environment that's used to predict severe weather, like surface flow, something we call helicity, which is like, turning and vorticity in the lower levels, how much energy, we call that CAPE, is available, that you can basically look at all the atmospheric ingredients that are needed for severe thunderstorms and figure out where on a map, going back to maps, those are at, like where those best parameters are lining up. All that's at your fingertip. I mean, you can even do it on here if you don't want to use like a lap. So we've gone from that to big bulky laptops mounted in the car using data cards, where you had to have like a data plan, to now you have Starlink.
Yeah.
So you can have dedicated internet. There's more chasers using Starlink, or I can tether, off this, or my iPad has a data plan, through AT&T. And you don't even have to have all that external equipment to pull, or running USB cables to tether. So, and then like you said, I don't have a drone, but yeah, now people are flying drones into tornadoes. It's just live streaming.
Right.
It's fascinating how far technology's even in the last 10, 20 years.
Is it fair to say that it's a fairly underfunded program, I guess, storm chasing in general? Like, is that funded well? Are you guys able to receive grants or anything to continue your studies with that? Or is that just something that, as a collective, you just want to do for the betterment of?
So most storm chasers are hobbyists. They're just out there, or they're independent, like stringers that are have a fascination with weather, and are hoping to maybe come out ahead financially by selling content or through live streaming on YouTube or something like that. Now, there's a separate component, which is the science component, which is dealing with like NOAA and the Commerce Department. They can and have gotten federal grants to go out and do field research on severe weather. That's a very small niche, like
Yeah.
that is a very small segment of the storm chasing community, and it is limited because it's not like there was a project called Vortex that went on. That stuff has basically a life expectancy. You know, they might have a grant for so many years and then it's done, and it's targeted to a specific area, or like studying a specific, like what causes large hail or what causes straight line winds, or specifically, you know, tornado genesis, you know, things like that. But there isn't, to my knowledge, ongoing regular funding through NOAA, which I know we're going to talk about NOAA, or like the Commerce Department, the federal government, for consistent storm chase research on that broader scale.
Gotcha.
And then universities will sometimes fund, you know, because that's what higher education, one of its core functions besides teaching is, you know, research and quaternary endeavors, like contributing to science. Meteorology is a science. Universities can sometimes, in their own accord, fund their own endeavors to take students out in the field and do research on specific topics. But again, that funding can be narrow and limited.
Mm-hmm. I think it's probably the best thing to get students out there getting that real field research and really, you know, able to identify different cells and everything like that.
Forecasting has been in the news for a different reason lately, though. The National Weather Service, NWS, has lost over 600 staff nationwide, and reduced staffing is scaling back weather balloon launches, which you talked about, that feed the models. From inside the field, how real is this impact on the forecast you and your other forecasters make?
That's a good question, but it's a little bit tough for me to answer because I don't work for NOAA or the National Weather Service. So it does make model output less accurate. So certainly the models have struggled with accuracy from the, you know, the paucity of weather balloon observations that we've had. That much is true. On the other hand, certainly forecasters are still able to apply their conceptual knowledge of past and present events to predict the weather. So I won't say that like it's handicapped forecasters to the point that they can't continue to make accurate forecasts, but it certainly makes it a little bit harder to have that accurate modeling. But also, forecasters don't live and die only by atmospheric models. So it's kind of a mixed answer on that.
NOAA also retired its 45-year billion-dollar disasters database that tracked the cost of major weather events. The tool was archived with no updates planned beyond 2024, though outside groups like Climate Central have stepped in to keep counting, putting the total past $431 billion events and $3.1 trillion since 1980 as of 2026. Does losing that kind of long-term federal tracking actually matter to a forecaster like you, or is this just kind of a researcher's problem?
So I actually hadn't heard about this until you printed this, so it wasn't something I came in with a lot of. I knew about the 600 staff cuts and the weather balloon cuts and stuff. So I guess my response to that would be, not speaking for like the NWS, I wouldn't see this as something that would impact immediate, like short-term weather forecasting, but I can see where not having that type of data to track costs of past weather events could impact data collection in the future to try to make comparisons between past and future events. I mean, certainly it would be, maybe I could say it would be akin to saying we weren't going to keep records on like some aspect of military service in a war. So then future historians wouldn't have that to look back on to make comparisons and analyzing, you know, the past and comparing it to the present, that type of a thing. So will it impact like short-term weather forecasting? Probably not so much, but it's still losing a tool to be able to look back and analyze. Like, let's say right now there's a pretty significant heat wave going on in Europe. Now, there was a big heat wave historically. I taught AP European history for a while, 1540. There was a massive heat wave that led to some famine and a dysentery outbreak in in Europe, killed a lot of people. Then we're talking like high Renaissance coming out of the Middle Ages here. But if we didn't have record of that,
Yeah.
we wouldn't really have anything to compare. And obviously, records in the past they were nowhere near as meticulous as they are today. So a lot of times when they say like this is the worst heat wave, our data on weather doesn't go back as meticulous it is now 5, 6, 700 years. But we still have written record this happened.
Mm-hmm.
And they did have ways they could measure temperature. It wasn't as maybe scientifically accurate as it is now, but there's a reason why the whole term "well, the mercury's rising" goes back, or it's rooted in history. But yeah, I mean, I certainly don't want to advocate that it's a good thing to lose that. I'd say that to answer your question, it's more of a researcher's problem than it is a forecaster's problem. But it does. I mean, from a climatological perspective, not having that data is probably going to be more harmful than an immediate meteorological. But it is also nice because people if we're going to say like this heat wave is going to be in the 90th percentile or something, people may want to know like, well, what are you comparing that to? And it helps with public messaging.
Right. Kind of compare and contrast.
Yeah.
Do you think, based on past events, I want to get this straight, like climate and weather, two different things, but we are constantly seeing people deny climate change. Do you think we're going to move towards more disasters, bigger weather events due to the changing of our overall global climate? I think we're on an uptake of these major weather events, hurricanes, tornadoes, touching down more frequently. Is that something that you foresee happening more?
I know that's something being studied, and I don't have a particular expertise in climatology. So that gets outside of my area a little bit because I'm more in the immediate weather forecasting. But I certainly think that that's absolutely possible because you're seeing like changes in the positioning of air masses and movements of like moisture and air currents. And so when you see like climate zones change and the earth tries to balance itself out, absolutely, that's certainly reasonable or possible. Case in point,
Yeah.
let's take, for example, ocean levels rising.
Mhm.
That puts a small island basically under 8-10 inches of water that wasn't under for those people, that's a catastrophic change that basically completely upends their way of living.
Mhm.
So in the one local example like that, more of a maritime one, absolutely, you got to leave. Like you can't live there anymore when what used to be inhabitable is now under 8 inches of water or whatever it ends up being.
Yeah.
I'm just throwing that out there
Sure.
because let's say like sea levels are rising, or maybe there's areas like I have seen certain predictions. I don't know if this will. I hope it doesn't. That large parts of North America up to the Dakotas would become a desert by like the year 2100. But certainly, if that happens, if where we're sitting right now in 75 years is a desert, it's an arid climate, it's going to or just let's say it's just more arid. We have a lot of agriculture here.
Yeah.
You aren't going to be the Corn Belt anymore if that comes to fruition. So it's certainly something that we have to be cognizant of and try to stem the tide so that it doesn't come to fruition. Obviously, like we're trending towards a lot more energy efficiency. Electric vehicles are becoming certainly.
Yeah.
There's been a lot of stepping up of the game, but I even tell my own geography students just trying to reduce, reuse, recycle. Why does that hurt? It doesn't hurt. It's not like it's not going to. You're not out anything if you're wrong. And certainly there's value, I believe, in trying to reduce our carbon footprint. Even if you're convinced or not convinced that like anthropogenic, we're not harming anything by reducing our carbon emissions. I don't see it as a negative.
100% agree.
I'd like to talk a little bit more about AI because that's been in the news lately and will continue to be in the news lately. But NOAA, they rolled out a new generation of AI-driven global forecasting models, and I wanted to ask you: do you regularly either just use AI in general or specifically for forecasting. And I bring this up because I read a cool stat that physics-based models actually perform better on average than AI-based models, which I think is really interesting. So I wanted to ask you.
There's a couple that I look at, but I view them like any other model. They're a tool. I don't know what data ingestion they have to feed their output. I will say there's one that's become kind of popular, and it's called StormNet. It's been doing a fairly good job with predicting some of these, like the tornado event we had in Illinois on Sunday. It nailed that pretty well. So their models are a tool, but they are not the be all end all. And forecasters have to use their conceptual knowledge and understanding of the atmosphere. They have to look at satellite, they have to look at radar, they have to look at upper air patterns to make a prediction. You can't just rely 100% on models. So it gets great to have another tool. I don't know what things are going to look like in relation to physics-based models in 10 years, but no model is any more valuable or accurate than the data ingested into it to give outputs. So you always have to keep that in mind when you're taking that output and kind of trying to relay it to, okay, conceptually what's going to happen here.
I know that we were previously talking about hurricanes as well. Have you ever been close to a hurricane event?
Not. That is one phenomenon I have yet. And the real reason is the most active part of the hurricane season, we're always in school.
Yeah.
It's typically September. I mean, obviously, like hurricane season starts June 1. And you can even get tropical systems earlier than that, like in May. It's not like it's unheard of. But I just don't have the ability until I retire to take a week off to go, because the problem with chasing a hurricane or tropical system is you can be stranded for an indefinite amount of time because the airports aren't going to be open. And you can have massive amounts of flooding. It's just never worked out for me that I've had a system that I was able to during prime season, like late August, September, October, and actually even into November, because typically we're in school.
I'm really glad you brought up tropical storms and hurricanes because lo and behold, last week, the 2026 Atlantic hurricane season's first named storm, Tropical Storm Arthur, made landfall in Texas and kind of, I wouldn't say destroyed, but did a lot of damage to the southeast United States, specifically Texas, Mississippi, and Louisiana. And you talked about how the hurricane season, tropical storm season begins June 1st. I want to kind of get your take on like what are some of your predictions for the rest of this so-called storm season, and why is it that the storm season begins on June 1st or in the second half of the year? Could you explain that?
Well, it's okay. It's all about, in the simplest answer, and this is an overly simplistic answer. It's really about, and we're talking the Northern Atlantic and Pacific, right? It's all about on a planetary scale with the tilt of the Earth in relation to the sun. You start to get more direct sunlight north of the equator. Well, we just had the summer solstice, 2 days ago? So on a planetary scale, it's really tied to the movement of air masses between the poles and the equator. But remember, water is slower to heat up and cool off than land. It behaves differently with temperature absorption and retention than land masses do. So if we put up like a globe or a global map, there's quite a bit of ocean, but it takes a long time for that to heat up, and it will retain that heat as you get into the cool months of like October, November. So those what's called sea surface temperatures or ocean temperatures are still warm enough. And even though we're seeing less sunlight, we're starting to see, polar air masses work down from the poles. And so it might be 25 degrees here on November 15th, but they're having a hurricane in Florida. Well, they're further south in latitude, so they're getting more direct sunlight. Their overall temperatures the Florida Keys are fairly mild year round, but those sea surface temperatures remain warm until you really start to see a drop off in that direct sunlight, but then they're slower to lose that heat. And it really is all tied to rising air and water temperature.
That's a really good in-depth explanation. And you already kind of answered this question earlier, but I want to kind of get a more of a definitive answer. parts of the western U.S. saw historic snow droughts earlier this year,
Okay.
while other regions got hit of severe flooding
Mhm.
because of these severe storms. And I believe the term for this is weather whiplash. And Aiden kind of alluded to this, but do you think instead of just having things are going to get more extreme with this climate change, do you think we're just going to have more of like these event extremes, kind of like what Aiden was talking about?
That's certainly possible, and I will say that like in weather and climatology, and again, I'm not a climatologist, but things seem to somehow all balance out. So like I know when I've been in Arizona visiting my mom in the winter, when it's below normal and they're having like, let's say, a really cool winter or really cool summer, we tend to be warmer here. So there's a drought somewhere, but somebody else is also dealing with flooding.
Right.
And it seems like in the grand scheme of things, like if there's and I guess at a simplistic level, it's all tied to what we call on a broader, planetary scale or synoptic scale, troughing and ridging. So like if the West Coast is in a particularly stormy pattern because there's a lot of, troughing there, there's probably a blocking pattern over like maybe the Western Great Lakes where we're having some sort of like abnormally dry or nice weather or something like that. So on a planetary scale, it's all interrelated. To put it basic,
Yeah.
in a very basic level.
I really enjoy how it kind of evens out, throughout the region.
Like we've had several dry years here.
Yeah.
Now we're having
Yeah.
a wet
Go
spring
swimming.
and summer.
Right.
I mean, you don't unless you're in an arid climate,
Mhm.
you don't categorically stay dry forever. But you'll have years where you go through periods where the last 3 years, the farmers were all telling me our soil moisture levels were low, lower than they like them to be.
Yeah.
Now we're in a period where it's too wet.
Yeah.
And that may continue for another year or two, but we'll certainly have another drought and we're going to have more floods.
Right.
It's kind of like an ebb and flow type of thing with weather. Nothing ever stays static. And even as we've talked about, climate zones can change or moderate. There can be, but that's a little bit of a separate topic.
I'd like to kind of close out some more storm chasing. And the question I have for you, because you've done it for quite some time, I've seen your pictures and photos on Facebook. They're just amazing. I'm very envious. But how can somebody who wants to maybe get into storm chasing or spotting from like a closer level, like maybe get actually in front of the storm, how can they do so safely? And I bring this up because several weeks ago, there was a pretty big storm. We had a tornado. We had a tornado warning. It wasn't the most recent one, but there's a tornado warning. We could see the supercell above Macomb, and Aiden were like, "Let's go. We gotta go. We gotta go
Yeah.
spot this." And our parents were like, "No, you're gonna get hurt. Get in the basement right now." And we kind of submitted to their
We went to the
please.
front porch.
We went to the front porch and saw this,
Okay.
but
Good.
I think something both of us want to do is actually go and safely, keyword safely, spot and kind of chase these storms. So how can someone do that?
There's several. I mean, you could start like I did as a kid. YouTube wasn't a thing. The internet, when I was a kid, we didn't have internet. We didn't get internet until I was in high school. So you can read books. There's all kinds of content on YouTube. I'm talking educational, like people that'll teach you about storm structure. What to look for. A great start is the National Weather Service every spring in areas that typically see severe weather, which in the U.S. is primarily all 50 states have or have had severe weather, but your primary zone of most active severe weather is between the Rocky Mountains and the Appalachian Mountains. So in areas that frequently see severe weather, the National Weather Service will offer spotter training courses. They typically offer them like in each county or in maybe like a region, like a group of counties, like Macomb has one every spring. A great start would be to just go take the National Weather Service spot and become a trained spotter. The National Weather Service does an excellent job with that. Resources online, read, educational. Granted, there's things to be learned from watching Storm Chaser video, but Storm Chasers aren't marketing video to educate people on storm structure. That's not their angle.
Mhm.
So you're not always going to learn. You can learn things from them, but you're not going to learn how to chase and what to look for unless a chaser's making something specifically geared. And I don't make any of my videos that way to like, oh,
Yeah.
this is just let's go on an educational journey. That's not my angle when I'm looking for things. You can always ask to go with somebody that knows what they're doing as long as they're comfortable with the liability.
Right.
But we are, man, and this goes back to like Talkville in like the late 18th, early 19th century. America's a litigious society. Well, and it kind of always has been. Some people may not be comfortable taking on the risk of taking people that with them, and because there is a risk, something could really the biggest risk is an auto accident or something like that. There are also tour companies.
Really?
Yes, there are tour companies. I drive for one of them.
Oh, okay.
Tours out of Denver, but there's multiple. There are tour companies that you do pay. Obviously, it's not free, but for a fee, they will take you out and they will put you there. And that's probably the safest way to do it. If you want somebody to do the work for you, and you want to get like right in there, but also learn a little bit doing it, go with somebody that'll let you go or go on a tour.
Yeah, that's fascinating. I didn't know that.
There are tours. There's I can think of 5 or 6 off the top of my head. I work for Silver Lining Tours out of Denver. I drive.
Okay.
It's owned by Roger Hill. He's in the Guinness Book of World Records.
Roger Hill.
Roger Hill, having seen the most tornadoes of anybody documented, so you look that up. I mean, I drive for them usually once or twice a year, but I would be remiss if I didn't ask you. There's other companies that do it.
Yeah.
You can get online. You could or find somebody local that would let you. Is comfortable with the liability, would let you ride along. And then it's not a spectator sport, so you learn by doing.
Fantastic.
So now I really want to ask if you're comfortable revealing, are there any specific set of gear or equipment that you use when you go out and do kind of your like high level spotting and chasing?
I think the thing that I probably use the most is the radar. Like, where am I at in relation? Because there's things happening in the storm you can't see visually. Not all. You can't always see it visually. Like, because of where I'm at, I may not exactly know if I'm driving north. Where's what's called the hail core? How far is it in relation? Because you can see visually like white streaks, but you may not always know where you are in relation to the hail core, or you may not be where you're at. You may not be able to see the counterclockwise rotation in the storm, but the radar will show you exactly where you're at in the upper levels, where that rotation's at if you can't see anything visually. So for me, of anything else that I use, it's probably that in map software, like Road Network, so I can navigate from of any two things. Those two are probably paramount. There's certainly other tools that we look at, but of those, and of course having internet.
Yeah.
Obviously the ability to but it can be done entirely visually and entirely old-fashioned, but I don't think most chasers anymore with the technology available. Why not?
It's nice having a computer at your fingertips. You mentioned wanting to, or whenever you retired, to hopefully go hurricane chasing. Is that something that you think you would do as a full-time hobby when you retire?
I don't know about a full-time hobby, but I could see myself getting out and doing a lot more chasing when I'm just in general when I'm retired, because I'll also have the ability to do that more in the earlier season, like March, April, May, when we're still in school. I'm usually not able to get out other than weekends till Memorial Day. So you sometimes miss out hurricane season. So I anticipate doing more of it when I retire. I don't know about full-time, but quite a bit more than I currently do.
Our last question to end this podcast. Given everything we've covered, what is one thing you wish that the average person they could do that when a heavy storm comes to better protect themselves?
That's a good question. Okay, I think the average person just needs to have situational awareness to know if there's a warning and you're in it, what am I supposed to do? If it's a severe thunderstorm warning, go indoors and stay away from doors and windows. You standing out on your front porch, you could, believe it or not, of all the storm chasing I do, lightning terrifies me. I am very afraid. So if we start getting heavy lightning, I'm in the vehicle. I do not want to be struck by lightning. Even though statistically, I'd have to look this up. I think you might have a better chance of winning the lottery, but I could be wrong on that. But it is a low probability.
Yeah.
But I also know doing what I'm doing, I'm putting myself out there. So I'm more likely to be struck by lightning than either of you two are.
Right.
But I also know people from earlier in my life. I know two people and they weren't storm chasers, that have been struck by lightning. So just, for severe thunderstorms, it's really not safe to be out in it. You have to have situational awareness. I mean, same with a tornado. If you're certain the tornado is going to be nowhere near you and it's passing 4 miles north and you want to go out and take a picture, sure. But I mean, if you're in the tornado warning and you know nothing about storms, you don't know the path, you don't know if it's coming, then the safest thing to do is get in a sturdy structure and get to the lowest level. Because if you know nothing about severe weather, if you don't understand storm structure, there's things like somebody that I know to look at that I can walk outside and tell you we need to be in the basement or we're fine. But the average person doesn't have the ability to discern that. So you have to use situational awareness if you don't want to become a victim.
Mr. Jesse Risley, thank you so much for coming on our podcast. This was very informative, and weather is something that I really enjoy. It's kind of like a side hobby, much like Aiden as well. So we really are thankful that you agreed to come on our podcast. Thank you.
Yeah, you're welcome.